Okay, we're in industrial electronics doing project number 6, which is a Coke machine. I'm going to open a new guy, the Micrologic 1000 DH45 slave guy. And first thing I'm going to do is I know I'm going to have some subroutines. I can't use ladder 2, I can't use ladder 3, I can't use ladder 4, I can't use ladder 5. So my first subroutine is going to be ladder 6. I just did a right mouse click. I'm going to rename ladder 6, take money. And then I'm going to rename ladder 7 as give product. And I don't have enough letters for that, so that's good enough. And I'm going to rename ladder 8 as give change. So now my subroutines are named, and when I click on them, it says take money on the top. Okay, back to the main program. Now notice that both main program and take money are at the bottom here, and I can click on those tabs. So I can go back and forth between those programs if I wanted. I need 1, 2, 3, 4 runs. Maybe 4 runs. And start with a binary bit, B 3:0/0. Well, I'm not going to do that. Well, maybe I'll do that. I'll add another run. We'll start with the first pass bit. So I come over to my status register and I see my first pass bit is S2:1/15. 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 Do it again. Okay, and it says it's the first pass bit. And we're going to go look for the clear guys. There it is. In the move logical spot, I have a clear. So I'm just going to put that in. I don't know what's going there yet. I'll worry about that later. All right, so my first bit is a credit bit. So I'll rename this guy credit. And then I'll throw in a subroutine. I gotta go find the subroutines. And program control. Label subroutine, no. Label, no. Jump to subroutine, yes. So jump to subroutine. The subroutine we want is 6. And that's going to be a U:6. Why U? I have no idea. And it looks like all it wants is, doesn't even want the U. Just wants a 6. Yeah, okay, 6. Fine. How come it didn't describe it? Okay, take money. Alright. Then I'm going to have a normally open contact. And 3 of them in a row. Probably 3 of them in a row. E3:0/1. And what do we call this guy? Credit. Alright, and this guy's supposed to be B3:0/1. And completed giving product. Completed. this is B3:0/2 completed given change. And we need 2 more subroutines. So what happens during the scan of the program is I get to the first subroutine and I go there, I execute that subroutine until the end run, and then I come back to where that subroutine was and I continue the main program scan. So that's how we're going to do that. This guy is a 7, which is give product. And this is subroutine 8, give change. Okay, and then we're going to put clears back in, and I don't know how many I need for that. So my main program is going to look like that. If I look for errors, I say I'm still going to have errors because I don't have anything in the clear response, but the other programs will be okay. So that's what my main program is going to look like. Now I'm going to go on my inputs and outputs set. Yes, I'm being told what to have there, so I better label them before I go on. So I'm going to use N7:0 to store the money. Okay, so we come down to integers, and N7:0 description, store money. I don't want to use him for anything else. That's what he's supposed to be used for. I look at input 1. So I open up my inputs. And input 0 is for 5 cents. And input 1 is for 10 cents. And input 2 is for 25 cents. And why are we doing half dollars? Anybody have any half dollars on them? I didn't think so. Alright. Yeah, because somebody might have a half dollar cents. What bigger? That guy there? See, that can be bigger, but not what, well, unfortunately it can't make bigger what you want to make bigger. Down here, it won't do that. But it's not going to make those guys bigger. Okay, so input 4 is going to be $1. Input 5 is going to be used for our coin return. So someplace in the program we're going to allow coins to be returned. So I put my money in and I want it back. I should be able to coin return and get my money back. Once I start getting product, I probably can't do that anymore. So, but someplace in the program I'd have to do that. Coin return. Then we'll go with a Coke. Now this is where you can be a little more individualized. If you don't like these particular beverages, you could conceivably pick a Budweiser or you know, somebody like Chris probably drinks 55 light or something, so 55 light. You don't necessarily have to call the product my product. Say again? I open the input file, and I'm naming all the inputs. You're right, that's in the wrong spot. No, I'm in the right spot. I'm using my piece of paper that's telling me what the inputs are and telling me what the outputs are, and I'm labeling them up front so that when I use them in the program, I will know what they are. Okay? And I don't get confused by using it for something other than that. So that was Diet Coke. And then 8 will be Cherry Coke. And of course I will take off for misspelling of Coke. 9, Diet Cherry Coke. And 10 is vanilla. And of course you'll have to take off total points if you do something stupid like put a Pepsi product in. Okay, so now I've labeled all my inputs. Now I'm going to label my outputs. So I open up the output file. And output 0 is supposed to be Coke. And, oh excellent, output 1, Diet Coke. Output 2, Cherry Coke. Output 3, Diet Cherry Coke. Output 4, vanilla. Output 5, Diet. Output 6, we'll call out, so we'll put 6 a nickel. How do you spell nickel? Maybe that's right. And then output 7 we'll call a dime. And output 8 will be a quarter. Alright, so now I've gone and I put, let me turn off the volume, this guy for a little bit, my capture thingy. Okay, so we're back on live. I'm coming back into, I'm going into my take money, adding some runs. Take money. 1 too many. I'll get rid of it later. So I have an input. go to my inputs, which I already have labeled, and I put the 5-cent guy in, and the 10-cent guy in. Then I'm going to want one-shot risings. Now, what's the problem?
I think people don't understand why people are in the files.
Like who?
Can you link? So you can link the subroutine in your main program. You can take and link to your file. Oh, I see it now.
There's the main program up there. Here's the take money subroutine down here. Yeah.
So it's on the same program.
It's all in the same program. You don't write another program.
That's not my question. I actually.
No, in the same 500 program. It's all together.
Right.
Togetherness. I guess we need to add to the curriculum more hugs. All right. Well, anyway. So I've got. Now the issue is. Did we or did we not use binary bits in the first instruction? And the answer is yes. So B0, 1, and 2 are already used. So the next binary bit is B3. B3:0/3. And we'll label that as one-shot rising, ladder, L for ladder, 6, R for run, 0. So I'm going to label my one-shot rising the ladder that I'm using it in, ladder 6, and the run it's in, run 0, so that I don't ever use it someplace else. The one-shot rising is a binary bit unique within alone. It doesn't want to be shared. Okay? I'm going to do the same thing here. B3:0/4. And I'm going to call that one-shot rising, ladder 6, run 1. If I could write a 6. Pretty much. And then B3:0/5. What the heck? B3:0/5. One-shot rising, ladder 6, run 2. B3:0/6. One-shot rising, ladder 6, run 3, I think. B3:0/7. One-shot rising, ladder 6, run 4. Now what happens if we hose ourselves over and we put another run? We decide we want to run there, and now all our one-shot risings are off in description by one run. Are we hosed to these, or do we just understand that we did that? As long as they're uniquely labeled, if we have to add something in there, I wouldn't go back and relabel everything.
Another binary bit is
Yeah, so clearly my labeling routine is unique to the ladder and the one I'm in. I want to be confident that that would be correct for what I'm moving. If I have to move it, I'm not sure what I would do. I might, if I was getting paid by the hour, I'd go back and change it. Right? If I was being paid by the line of code, I would probably not change it. Okay, now I got to find my add instructions. And they're someplace in here. I just know they are. I skipped them already. There we go. Math. So there's my add. Yeah, what's your quick question? No. You have several choices there. You could have your binary bit guys open and bring the address over like that. You could do it that way, or you could type it B3:0. No, you can't type it because I'm not there. This is credit. That's the wrong guy. B3:0/3. So no, what you type in, the addressing of what you type is not how it appears because the bit ends up on the bottom. But I can change this bit once I get it in. I can put a 5 there. I can put a 4 there. I could do that after you got it there. You want me to go up? Down. Okay, so I'm going to put an add instruction there. An add instruction there. Add instruction there. And I'm going to add N7:0. I'm going to add 1. N7:0. Maybe. Go N7:0. 2. N7:0. N7:0. 5. N7:0. N7:0. 10. I'm not going to type it anymore. I'm just going to bring it down. N7:0. N7:0. 20. Bring it down. And then I'm going to take my compare guy. Compare. I want a greater than or equal to guy. So I'm going to look at N7:0 greater than or equal to 19. And I'm going to then latch my credit guy. Latch credit. And I have a problem in run 2 and run 6. What's wrong in run 2? Oh, that's file 2. Okay, so the only problem I have in this guy is down at the end, so. Okay, so I don't have any problems with taking money. And now I'm showing it all at the same time, but if I do that, you can't see it, so that's pretty dumb. When I set the credit, do I want to set the credit before or after all my inputs are zero? Do I want the coin to go all the way through and all those switches to come back up when my inputs are zero? So what we're going to do is we're going to throw in another compare, and we're going to throw in an equal sign. Well, if we throw in an equal guy, okay, we'll do that. We'll throw in an equal guy and say input 1:0.0. We want it to be 0. But what this will mean is that if somebody's holding the button for a product and he puts in the last nickel, he won't be able to choose a product until he lets go of that button. It also means that as long as the nickel is falling past the switch, I won't go to the Give Product program until that switch goes back to 0, which is really what I'm looking for. I'm looking for that switch to go back to 0 before I latch that credit. And that's gonna solve. Say again? Source A is input. The input 1:0.0. That whole word of input. Those are all my nickels, all my lines, all my things, all my product vectors. They all have to be mapped up before I'm going to latch this credit and allow me to get product. And that's going to solve problems. Either we correct it here or we correct it in the Give Product. Either way, it has to be something that's corrected. Oh, there we go. I'm going to get to Give Product. I'm going to add some runs. So I need a not equal. So in the compare guy, I look for not equal. So the inputs I1:0.0. If it's not equal to 0, we want to do something. We want to not equal to giving product. Okay, so we're going to go and look in our cross-reference file, and we're going to see that the last binary bit guy we used was 7, so this guy is going to be an 8. B3:0/8 giving product. What was the question? I look at the cross-reference file. I've already used 7. The next guy to be used is 8. All right. What? I'm in ladder 7. Give product. Isn't your ladder 7 give product? What do you mean yours is square?
Give product.
multiple times at the same time. That's what I was going to turn off. It wasn't something that you're supposed to put down because it doesn't work. All right, now I need to find the encoder. And they've already been under something like shift registers. There we go. Shift registers. No, not the encoder's not there. It's advanced math at the very end. Yeah, there it is, encoder. So there's the encoder. And then I want a decoder also, so I'll just put them both down so I don't have to go back there again. Okay, so I want to encode I1:0.0 to 7:1 and 7:1. And then I'm going to decode N7:1 into N7:2. Way to go. N7:1 into N7:2. And then I want to latch a bit that says I'm giving product, so I never do that again. So I do this once, I never do it again. Okay, now that I've done it, I'm going to start a timer. So I'm giving product. I'm going to start a timer. T4:0. And this is going to be 0.12 second shifting timer. But you can call it anything you want. I mean, you don't necessarily have to call it that. Preset's going to be 12. Okay. And with that timer going, T4:0.ACC/0, the 0th bit going, I'm going to do a shift register thing. And bit shift right. Okay, file. What file am I using? N7:2 is the file I'm using. Giving product integer. I haven't used any control stuff. R6:0. Bit shift right for product, for giving product. Now I need another binary address I'm not using anywhere, so I come over again to the cross-reference file. The last guy I used was 8, so I'm going to use 10. I'm going to use 9, okay. B3:0/9. Thank you very much. B3:0/9 for use with 2, so I don't use it anyplace else. Now, the length is something that's cool, and I think the length, we'll have to look and see what the length is. I'm not sure whether that's a bit length. Well, I am pretty sure that that is a bit length. And but we're going to go to help and find out. Help, instructions, bit shift right. On each true-false transition, the output instruction loads a bit into the array, and the pattern through is then shifted right and unloads a bit of data. For example, enter parameter blah 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 blah. Okay. Warning: do not use the same control address for any other instruction. Blah 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 blah. Size. Word 1. Size of bit array, number of bits. Okay, so this is a 16-bit word. File. The file address of the bit array you want to shift must have a blah in front of it. You must start the array at a 16-bit element boundary. For example, bit 0 of elements blah 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 blah. Control element bit address length. The total length of bits to be shifted. Okay, the total length of bits to be shifted. Alright, so that's what that is. And this has a thing got it. Okay, so I think I know what that means. So we'll make the length be 16. Alright, so I think that's going to work. Whatever you want to put on it is fine to go with you. So I put on bit shift right for a given file. No, I'd rather get to the rest of the program before the end of the period. So now we have the issue of the timer being done. So T4:0/done. So the timer's done. We're going to start another timer. T4:1. And this is going to be a half second giving product timer. With T4:0 timer timing, timer 1 timer timing. Timer timing. We're going to do a move. And we're going to move N7:2, N7:2. And we're going to do a mask move. That way, if something messes up, we won't be giving money. So we're going to do a mask move, and we're going to go with N7:2, and we're going to go to the outputs 0:0:0.0, and then we're going to ask ourselves, what should the mask look like? Something's sitting there that could end up giving out some money, it won't. So T4:0. Okay. Doing T4:1 is done. We're doing a clear. So we're going to clear the outputs. Latch completed giving product. Anybody remember what the completed giving product bit was? And I don't remember what it was either, so we just come back here and completed giving product is 0, 1. B3:0/1. And we'll do a check of the program. Okay. Now we will do, where would you like the program placed? All the way to the top? How cool?
Very last thing you did. Yeah.
The last thing is our last completed giving product. Do it without the encoder decoder, but then it was difficult to, and that would also give you a priority, because as soon as you got to one of them, you would have to the other. You could go last product, but you could also go last given product, and pull that out too. So as soon as any of them match none of them, terrible looking. It just didn't look elegant at all. Oh, I hope so. Why?
I was going to ask you if you could help me sign up for my classes.
What makes you think you can sign up for them today?
I can in 5 minutes.
5 minutes?
Isn't it the 4th?
Oh, it is the 4th, April 4th.
I didn't want to he had to fool himself.
Sure. Oh, I don't
Gotta
blame
sit
him.
around for 72 hours.
You'll be able to print a couple, few pages of that?
I don't know why I need to. Now we have to, yeah, the big change will be on this, right?
That works.
The rest of those big change, well,
I wish we could get done with electronic devices and just do this calls. Did you? $80 for gas.